Thank you, John, and thanks everyone for being here today. I'm very happy to be spending the Sunday with you and having the opportunity to show you some of the tools that I've been creating with my students at MIT. And the way that I'm going to tell you this is by telling you a little bit about the personal story that brought me to work on the development of these tools. Because as John was telling you, I did my PhD in physics, and as I was developing through my academic career, my main interest was to understand different systems. And as I was in the work of understanding these different systems, I started to realize that in some way, the way that we were doing that, because of the tools that we had available, was limited. And one way of making progress was by changing the tools that we had to transform data into stories. So my story starts around 2006, 2007. At that time, I was a sophomore grad student at Notre Dame, and I was doing a sabbatical at Harvard in the medical school at the Dana-Farber Cancer Institute. And what was fun is that, I don't know if you guys can see from the way that I look, but I'm from this funny generation that nobody talks about, which is the Generation X. Because everybody talks about the boomers, everybody talks about the millennials, but in between there was a whole generation of people that everybody forgot, which is the one that I belong to, which is the Generation X. And we're kind of like in between because I don't think we're as tech savvy as the millennials, but we're more tech savvy than the boomers. And one thing that also differentiates us from the boomers and the millennials is that we didn't care that much. Okay? The boomers cared, the millennials cared, and the Generation X was like, for me, the main artist of the Generation X maybe was Kurt Cobain, which he basically sang about not caring about anything, okay? And that made us a little bit less confrontational, so we sat there, in between these generations, and I landed in grad school, and I remember my advisor at that time was relatively young. He was like an early Generation X person born in the late 60s, and what started to happen is that I started to discover that the boomers and the people from the early Generation X, who were the scholars at that time, had ideas, but they didn't know how to program very well, And you are young, and you know how to program better, and what starts happening is they start throwing data sets at you, and they say, Cesar, here you have a data set on mobile phone records for millions of people. Figure something interesting. Here you have a data set with medical claim records for millions of people. Figure something interesting. Here you have a data set with international trade data for the last 50 years for every country in the world. Figure something with it, because they were not able to wrangle the data because the data was, at that point, at a size that was larger than what you could put on a spreadsheet. Okay? So you needed to program. And I was kind of like that first generation of people that started to program that data in languages that by nowadays standards would be considered archaic, which would be Perl. Okay? And in that context, what happened is that I started working on these data sets, building papers, understanding systems, understanding how people interact socially based on mobile phone records, understanding how economies evolve by looking at the mix of products that they make and how those products change over time, understanding how diseases progress by seeing what is the probability that two diseases affect the same individuals. And I started to realize that to explain the stories that I was creating in all of these research projects, I needed to generate visuals. And all of a sudden I started to realize that the visuals that I started to generate, sometimes they were the ones that stole the show. They were the things that people found more interesting, and they were able to encapsulate almost the entire story in one single picture, and they were what spread. So around 2006, and then in 2006 I created this chart, and then I was publishing a paper in Science in 2007, in which I started to look at the mix of products that countries make, and I created this representation that is called the product space, which I'm going to explain into detail later, and it became very popular. And what started to happen is that as I created a research paper that became popular and that was very applied because it helped us understand how the mix of products that a country makes evolve over time and why some countries are rich and why some countries are poor, there was a lot of people who started to write emails to me and say, Cesar, can you do a case study for my country of Morocco? Can you do a case study for my state of Minas Gerais within Brazil? And to be honest, I thought that it was very nice that there was people that was paying attention to the research that I was doing and that they wanted to apply it. But creating all of those charts all of a sudden became a burden because it required a lot of hours of my labor, and it was work that for me was repetitive. So when I started my lab at MIT in 2010, what I said is, you know what I need is when you do a good paper, you have to do customer service. Okay? But that customer service is expensive, and as you know, like research operations are very small in the number of people that they have. So what I need to do is to do like some sort of self-service, customer service for the papers that I do. So then I started to work on tools that would be machines that would transform data into charts automatically. So then when people would come at me and say like, hey, I would like to do the product space for Morocco, instead of me charging them some money for a consulting contract and then giving them a PDF that was going to be outdated after a few years, I could point them to a site that was always going to be up to date, and they can do that by themselves. So the first that we did was the Observatory of Economic Complexity, and that was the second version. Now we're in the third version. And this is a site that allows you to visualize all international trade data for the last 50 years. And it's a site that we have now grown to transform data into stories. So the nice thing is that now, let's say if you go to Google and you ask Google, what does Canada export? Google doesn't know, but what they're going to give you, is other than automotive industry, which is actually a very aggregate answer, they're going to give you a link to our site first. Why? Because our site is the one that provides you the best answer for what does Canada export. So what is the story that emerges from here? So imagine what we have here is on the back end, like a table that existed in the World Bank and the UN, for decades already. And on top of that, we build a stack of software that transformed that into a little narrative. Okay? So what you have here in the beginning is a little bit of text, and that text, surprisingly, is not for humans, even though it's human readable. That text, is for search engines. Why? Because search engines are a little bit stupid. Okay? Search engines were designed for a world in which the web was based on text, on pictures and video, but not for a world in which the web had data. So what we have to do is to transform that data automatically into text, and once you transform that data automatically into text, Google is able to identify that your page has the right data. So as a human, probably if you come to this page and you're searching for what Canada exports, you're probably going to go into this visualization that tells you that Canada actually exports much more crude petroleum than cars. So Google was kind of like a little bit wrong on that one, and exports refined petroleum, gas turbines, wheat, potassic fertilizers. But Google cannot see that visualization. Google doesn't know how to click, how to look at mouse over events, how to press radio buttons, how to explore drop-down menus, how to search within your site. So what Google does is reads that here it says, in 2013, Canada exported 438 billion, making it the 12th largest exporter in the world. Or when it says here, the top exports of Canada are crude petroleum. So when people search top exports, Google knows how to find that because of that text. So you see that all of a sudden you have kind of like a little narrative that starts emerging. You have the exports of Canada, you have the imports of Canada here, you have the trade balance of Canada, which for the most part has remained positive. You have the destinations that Canada exports to, and here all of a sudden you see something that is kind of like curious about Canada. Canada is a country that more or less has like one export destination where most of the products go to, which is the United States. Actually, Canada is more dependent on the United States in terms of exports than Mexico. Mexico is 72% of its exports end up in the United States. Canada is 73% of its exports. But all of a sudden, you might want to think that you want to deviate from this narrative. Maybe you don't want to look at like the destinations or the origins in this linear fashion. Maybe you want to look at, well, but Canada also exports to China. What does Canada export to China? And if you click there, you're going to have a set of follow-up questions. For instance, here it says, what does Canada export to China? What does Canada import from China? And when you click on that, you can deviate, from the linear narrative and now go into that question. So you see that what Canada exports to China are relatively unsophisticated things. They don't export too many cars. There's mostly iron ore, coal briquettes, copper ore, rapeseed, wheat, wood pulp, sawn wood, and so forth. Okay? So now you have a tool that you can use to explore this data, in a linear form with a prefabricated narrative, but also that you can deviate from that narrative, by clicking and doing follow-up questions and in some way create your own story. Did any of you read like this create your own story books as a kid? That at the end, said like, if you want the guy to enter the cave, go to page 15. You want the guy to go into the forest, go to page 7. It's a little bit like that. Now, you might wonder, why are we so obsessed in visualizing the mix of products that countries make and how this product mix changes over time? You know? Is it just curiosity? Is it just because the data is available and it's out there? And I originally entered this field not because trade data was data that I was highly interested in for hedonic or aesthetic reasons, but because the mix of products that a country makes allow us to predict some important things about the future of an economy. Okay? So here I'm going to show you two of those things, but in reality there are three things that we have been able to document that can be well explained by the mix of products that countries make that are important. The first one is that you can predict what a country is going to make in the future. So if I know what Canada makes now, or if I know what Colombia makes now, if I know what Vietnam makes now, I can much more accurately predict what they're going to make next than if I would be using a naive prediction criteria by saying they're going to enter the largest markets, or they're going to export products that are experiencing growth in the world and so forth. Like countries have path dependencies that can be explained by what they're doing at a certain point in time. The second thing is that you can predict what's the level of income that a country should have. Because the mix of products that a country makes is an expression of the talent and of the capacities that reside inside an economy. That's what I explain in my book, Why Information Grows, which is the idea that in some sense societies or economies are distributed computers, and by looking at the mix of products that a country makes, you can have a guess of the computational capacity of that country. So you can predict future economic growth. And finally, if you know the mix of products that a country makes, you can also very accurately predict the level of income inequality that they're going to have. Two countries that have the same level of education, the same GDP per capita, even similar population, might have very different levels of income inequality that can be explained by looking at the products mix that they do. Countries that tend to concentrate more on mineral resources and agricultural resources tend to be, on average, much more unequal than those that perform manufacturing activities. And there's a whole story of how institutions co-evolve with productive activities that we can use to explain that relationship. So let's look at some of these predictions and how a tool like the Observatory of Economic Complexity can help us look at them. So let's go forward to this one. And now here I'm showing a very different visualization in which I'm showing the products that Chile exports in 1979. In the previous, more simple visualizations like this one, I'm just showing them by share. And you see that Chile exports a lot of refined copper and copper ore, quite a bit of grapes, some wine, some fish fillets, and so forth. So here I'm seeing how big each product is for the Chilean export economy. Here, on the other hand, I'm seeing how those products are related to our products that are similar. So what I'm going to do here in the product space, I'm going to click on a product so I can illustrate that. And each one of these nodes represents a product. That node there represents crustaceans and mollusks. This other node here represents preserved fish. And this other node here represents frozen fish. But you see that some of these little nodes are connected to others. The nodes that are connected to one another are products that tend to be similar. Yes?
Could we dim the lights a bit? It's hard to see this light.
Sure. Yeah. Yeah. Thank you. Yeah. So you see that some products are connected to others, and you might ask yourself the question, well, how do I know that fresh fish is similar to frozen fish? And the answer is like, well, I don't know, but the data might be able to have a clue. So the way that I do it is I look at what is the probability that frozen fish is co-exported with fresh fish. And I say, if the countries that export fresh fish are also very likely to export frozen fish, there must be some similarity between them. Whether the similarity comes from geographical reasons, institutional reasons, human capital reasons, I don't care. That similarity is expressed in the fact that the one that tends to make one tends to make the other. So if I look at Chile in 1979 and I look at fresh fish, I see that Chile is not exporting fresh fish, but is exporting all of the products that are connected to it. So if I were to guess what Chile is going to make next, I should predict, export of fresh fish. Sounds like obvious. Now, if I would go to another part of the product space, for example, here when I have valves or pulley system parts, that's a product that has many connections, but none of those connections bring you to a node that is also painted. That means that Chile doesn't export any product that tends to be co-exported with pulley system parts, meaning that probably within Chile, there are no networks of people that hold the knowledge to produce anything that is similar to that. So if I were to guess if Chile was going to enter into that product in the future, I would assign that a very low probability. So what we can do here is that since we have 50 years of data, we can look at the future of 1979. And the future of 1979 is something like 1996. Okay? And when I look at 1996, I see that Chile now exports fresh fish. And I see that they also enter a lot of other products like vegetable and fruit juices that they didn't export in 1979, but that they were connected to products that they did export. So what I have here now is a tool that not only allows me to describe what a country is going to make, but allows me to predict what they're going to make in the future. And that is something that is valuable in the context of a world in which people sometimes discuss industrial policies using methods that are not very pragmatic. The other thing that I tell you that we can do if we know the mix of products that a country makes is predict the level of income that they should have, and therefore if that country is poised to grow or not. How do we do this? This is a little bit more complicated, but also involves techniques that come from networks. One thing that I can do is try to figure out if the products that a country makes are sophisticated, and if a country makes a lot of sophisticated products. Countries that would make a large diversity of sophisticated products are countries that should be able to sustain a higher equilibrium level of income than countries that make products that are simple and that are unsophisticated. Now the question is, how do you know which products are sophisticated? And how do I know which products are not sophisticated? And here there's like a very simple trick. The idea is that, well, if a country has a lot of knowledge embodied in its people, it's going to be able to make a lot of different things. It's going to be a very diverse economy. And if a product is one that is very difficult to make and is very sophisticated, it's going to be produced by very few countries, and the countries that are going to produce that product are probably going to be diversified. So you have a product that is very simple, let's say, cotton shirts. That's going to be a product that is going to be made by many countries, and the countries that make cotton shirts are not going to necessarily be diversified. But if I have a product that is very sophisticated, like X-ray equipment, that's going to be made by few countries, and those countries that make X-rays are going to tend to be diversified themselves. So I can use this information on how diverse an economy is and how ubiquitous a product is to create an indicator of how sophisticated that economy is. Okay? And that's what I call the economic complexity index. So when you look at the economic complexity index and you compare it with GDP per capita, you see that they correlate quite nicely, but there's many countries that do not align. And the countries that do not align are the ones that are, in this context, out of equilibrium, and are the ones that should either grow or decline. And this is something that if you guys are interested, we've validated in many papers and show that it's robust to a large number of controls. But what I'm doing here is showing data for 2013, which is a relatively recent year for which we have data for the entire world. And I see that, for instance, you have countries like Germany, Japan, or Switzerland that have very complex economies, meaning that they're able to produce most of the things that you could imagine, even the most difficult things, and are very rich. So they deserve that wealth. There are other countries, on the other hand, like Mozambique, or Mauritania, or Ethiopia, or Yemen, that have product mixes that are relatively unsophisticated. So the countries have low levels of income, but given what they make, you wouldn't expect them to have a level of income that is much higher, because they make things that everybody else knows how to make, and they're relatively simple things to make. But on the bottom here, you have countries, for example, like Philippines, India, or China. Like, if you look at India, India has an income that, like a complexity of the economy that is comparable to Greece. But Greece has an income per capita of 18,000, while India has one of only 1,200. So in some sense, India is doomed to grow because it's able to produce things that are comparable in its sophistication to things that are produced by countries that are much richer than it. The same is true for China. China is even more sophisticated than India and is comparable to Spain or to Norway in the sophistication of its economy. It's still not comparable to the US. On the other hand, you have countries that are too rich given what they make. What are these countries? Qatar would be one of them. They are too rich at $60,000 a year, based on the product mix that they make, mostly because they export a lot of mineral fuels that inflate that income. And you can imagine what is happening now that the oil prices are at the level that they are in countries like that. There is Australia too, which is also a country that exports a lot of natural resources. New Zealand, Saudi Arabia, Portugal, Greece, and Canada is also up there too, and Norway. which are countries that export a lot of natural resources. Canada, of course, is quite more sophisticated than Qatar. Like a 0.7 on economic complexity means that you are 0.7 points to the right of the average of the world, but still it means that the income is relatively high given the sophistication of the economy, and therefore there is a little bit of a disequilibrium that you would observe. So as you can see, these sites that help us visualize data and allows us to help us visualize data in many different ways, and not just sites that allows us to make pretty pictures, but they're sites that allows us to transform data into stories, and at the same time are Trojan horses that allows us to bring our stories to the masses. Why? Because the Observatory of Economic Complexity is a site that has a very simple way of entering. You just have to search, what does my country export? Or what are the top imports of some country? And you'll be there. And once you're there, you're going to start seeing the world from the perspective of the products that countries make, not from the aggregate macroeconomics variables that most people would look at. And in that context, you are providing people a door to start seeing the world, from your perspective. So it's not only a site that visualizes data, but it's also a Trojan horse that you can use to introduce your theories. So as you can imagine, when we started doing this work, some people, as I was telling you before, came to us asking us to do particular case studies for their countries, for their states, for their regions, and so forth. And in the beginning, the model that they wanted to push was more of a consultancy model that I didn't feel very comfortable with, which is one in which you're going to give you a bunch of money and you're going to give us a bunch of ink on paper. Hopefully that ink on paper is going to make some sense. Okay? But I didn't feel very comfortable with that because as I started to learn more about the consulting business, I started to realize that there was a lot of reports that were done that had very little impact, that they would end up in drawers, and in some sense we were going into a technical era in which we could make technologies that would make those reports obsolete. So if we could create technologies that would make those reports obsolete, then it was our responsibility to develop those technologies. As we say in the Media Lab, you are either the road or the rolling pin, and you better be the rolling pin because if you are the road, someone else will be that rolling pin that is going to roll over you. So if you can put yourself out of business, you should put yourself out of business first before other ones do, because your competitors for surely will. So in Brazil, they invited me to do one of these reports, and as a result of that, we created a site called Data Viva, which is much more ambitious than the Observatory of Economic Complexity because it makes available data for the entire Brazilian economy. This is a site that makes available data on international trade, labor, and education for all of Brazil. This data set is basically 50 million people, which is all the people that participate of the formal economy of Brazil. And it's at a high level of disaggregation. So we're not looking at the entire country, but we're looking at each one of Brazil's 5,000 municipalities. Brazil is divided into 5,000 municipalities, so we can look at the states, mesoregions, microregions, and the municipalities. We can see things at many different scales. So for example, we could say, well, the top exporting municipalities, let's look at São Paulo, which is one that many people might be familiar with. And when you load São Paulo, you'll immediately start seeing that a story starts to emerge. So the first chart that the site shows you is the trade balance of São Paulo. And what do you see there? Well, things were going quite well for São Paulo. The exports were larger than their imports, or similar in number until 2008 and 2009. Then during the crisis, they crashed. But the exports crashed more heavily than the imports. And since then, they have been carrying a huge trade deficit. Yeah? So you might ask yourself, well, what happened? Where did the trade deficit come from? So the nice thing about a site like this is that you can start digging deeper because you can disaggregate this data in many different ways. So you can say, well, what are the products that São Paulo was exporting? And you can see that they exported metals and they exported foodstuffs. What were these foodstuffs? Well, primarily was raw sugar. And you can see that the exports of raw sugar peaked in 2011 and then they tanked, just like the exports of metals peaked in 2008 and then they tanked. Okay? So you can see, well, there are these particular sectors, the one that explain a lot of that trade deficit. Yeah? These sectors did not recover well after the crisis. Were there some destinations that were the problem? So let's look at the destinations that São Paulo exports, and they export to Asia. And during the crisis, the exports went down, but then they went up again. But the exports to Europe went down, and then they never went up again. Well, where in Europe? Well, Belgium was a destination that was relatively important, was the second biggest destination in 2008, and now, it's a destination to which they export only 100 million when they used to export, 400 million, at its peak. Yeah? You can see also the products that they import, since they're importing a lot of products that are mostly machines. What type of machines? They're mostly like telephones, and digital disk drives. So it's all of the electronics, the ones that have been driving, a lot of like that trade deficit. Yeah? A lot of import of electronics, has been increasing after the crisis, but hasn't been able to be compensated by the export of soybeans or metals. Yeah? And where are those electronics come from? And you can see that Asia, particularly China, is the country which they're accumulating that trade deficit with. But if you want to step out of international trade, you can look at wages and employment. You can see the industries in Sao Paulo that employ most people. It used to be the public administration, okay? And now it's trade or the retail industry. It's mostly retail trade, mostly supermarkets. Those are the ones that have been hiring people in Sao Paulo economy. Basically, they have been hiring more people to sell those cell phones that they have been importing. What are the occupations, that are being hired? Also here you see the service and retail workers, mostly vendors. So everybody's trading stuff, I guess, that is being imported, but they're not producing that much anymore. And when it comes to the wages, who are the guys that get the wages? Well, the electricity and gas industry is the one that get a lot of wages. Production of electricity, production and distribution of gas. And what are the occupations that get the wages? Well, in this case, are the construction CEOs, financial CEOs, human resource directors, and so forth. So all of like the higher ups in the companies, those are the ones in which the wages have been increasing over the last 10 years. So as you can see, we can create these tools that can sit on top of large data sets and allow us to explore those data sets quite thoroughly. And if you're not interested in Sao Paulo, which is a large and rich city that could afford developing this resource, but let's say you're interested on a much smaller part of Brazil, you can find it as well. Because you can find, a profile for any location in Brazil, even if it's like a little municipality in a relatively small state, okay? So, you can go to like, let's say some Jundiaí, which is only 377,000 people, and you will be able to extract the same story, for them, yeah? In this case, the trade deficit has been much more gruesome. Now, you guys might be thinking, well, this guy spent all of his life looking at data on the products that countries make, the industries that are present in locations, and that's fine and dandy, but might be a little bit boring. And I will agree with you that it's a little bit boring sometimes. Huh? So I've been looking at other types of data as well, because I started to realize a few years ago that the description of countries or locations that we were pushing was highly incomplete. And one of the reasons why it was incomplete, because in all of these official government data sets that we had, we could see important aspects of the economy, like the mix of products that a country exports, or the occupations that are employed in a location, or the industries that are growing in a certain part of the economy. But we knew nothing about the culture that that economy produced. And a few years ago, I started to think about, well, you can think of the United States, let's say, as a country that exports soybeans and aircraft engines, but you can also think of the United States as the birthplace of Miles Davis and Neil Armstrong. And where do we count that? Does it count for anything? Are there interesting patterns also to be learned if we look at countries as places that produce culture or that produce memorable historical characters, not only products or raw materials? What I realized, though, is that that data did not exist. Neither the UN or the UNESCO or any country had good data on the memorable people that had been produced, by each country or each city in the world. So I decided, well, if that data does not exist, that's a good thing, because it means I can go and create it. So a few years ago, we started the Pantheon project, and the Pantheon project focuses on memorable characters. And the way that we do that is looking at the globally famous people that are born in a certain country or city in the world. Now you might say, how does Cesar know who is globally memorable? Maybe we all have different definitions of who should make it into history. And I would say, exactly, that's the point. Everybody has a different definition. So what we should do is to try to get some relatively small data set that allows us to understand some of the overlap of our definitions. And what would that be? Well, if I have someone, let's say, that is very famous in Canada, but is not famous in other parts of the world, probably that person is locally famous. It's not globally famous. How do I know if someone is globally famous? Well, because I'm going to be able to find documentation about that person in many different languages. So if I can read about that person only in English and in French, then that person might be famous within a local community. But if I can read about that person in English, in French, in Pashto, in Swahili, in Spanish, in Vietnamese, in Thai, etc., then I probably have a better guess of who is globally famous. And that's kind of interesting because if you look at many sports players, like for example American football players, they tend to have long, detailed pages on the English Wikipedia, but they tend to have presence in relatively few different language editions of the Wikipedia. Why? Because American football is a very US-centric type of cultural phenomenon. When you look at the page of Peyton Manning or Isaac Newton, in length, those pages are more or less equal in the English Wikipedia, but Peyton Manning has only a few tens of languages. Isaac Newton has more than 200. So we use that little trick, the fact that some people are recording many different languages in the Wikipedia to create a list of who was globally famous. So we went to all language editions of the Wikipedia, and we look at only people that have presence in more than 25 languages. Why 25 languages? Because in the first iteration of this data set, we had to manually verify each one of the entries that we incorporated in it. Why? Because if I tell you in the Observatory of Economic Complexity that Argentina exported $1.1 billion in soybeans, when maybe some government agency said that exported $1.2 billion in soybeans, who cares? Nobody's gonna, like come and complain too much about it. But if I tell you that Enrico Fermi was born in Rome, New York, and not in Rome, Italy, the internet is not gonna be kind to me, okay? So we decided to keep it manageable, and to manually verify it, and this is something that we're gonna see that happens a lot of the time, which is, I say I'm not in the business of big data, I'm a lot in the business of bad data, okay? And to transform big data into good data, sometimes you have to first manually do things, and once you manually do things well, you can then bring machine learning algorithms to scale that effort for you. So for instance, the Pantheon 2.0 dataset that we're generating right now is going to incorporate many more biographies, and the way that we can classify the occupations of those biographies, the cities that they were born in, the years that they were alive, is by creating a natural language processing algorithm that is trained in this first manually verified data set, and therefore allows us to scale that data set. So there is a little grunt work that always needs to be done when you're working with data. So before I show you the exports of Chile in terms of products, and here are the exports of Chile in terms of culture. In our data set, Chile has 27 people that have become globally famous. Some of these are writers, like Pablo Neruda, Gabriela Mistral, or Alejandro Jodorowsky. Some of them are politicians, like Pinochet and Allende. Some of them are soccer players, like Zamorano, Salas, and Sanchez. Some are tennis players, like Marcelo Rios, Nicolás Massú, and Fernando González. So you see, it's not a very diverse country in terms of its cultural production. Let's look at like a different country, for instance, when we look at Canada, and if we point, our visualization engine to Canada, you would see a much more, diverse group. You see that there are actors like Donald Sutherland, Mary Pickford, Jim Carrey, William Shatner that were born in Canada. Singers like Paul Anka, Bryan Adams, Celine Dion, Shania Twain. Economists like John Kenneth Galbraith, Robert Mundell. Chemists like Henry Thubaud. Physicians, wrestlers, writers like Leonard Cohen and Saul Bellow. Politicians like Pierre Trudeau. Even pornographic actors like Charles Tisley and Sunny Leon. Okay? So you realize that when you look, at the cultural exports of countries, you see large variations. And honest to God, when I created this project, my original intention was to look at differences in the cultural production of countries and try to explain why some countries, produce people from some occupations and not others. And there's a lot of structure there that can be explained. But what I realized after I actually built the visualization engine was that there was a more interesting story that was hiding, in this data. And that was the story of how communication technologies change how many people we can remember, and also what the things that we remember are. So what I'm going to do now is I'm going to point, this visualization engine to look at everyone in the data set from all countries. And here you see a grand diversity of people. You see actors, politicians, soccer players, physicists. But the actors are all born in more recent years than maybe some of the physicists or the religious figures. In the religious figures, the top three here is Jesus, Moses, Mohammed, Abraham, Martin Luther. The actors are more recent: Marilyn Monroe, Bruce Lee, Charles Chaplin. So maybe this matrix changes over time. And it actually does. And it changes in a very well-determined way. So the first thing that I'm going to show you is that actually when you look at the number of people that we remember as a function of time, this number of people that we remember in per capita terms goes through very well-defined transitions. And this might look a little bit complicated, but I think I should be able to explain. So on the y-axis of these charts, what you have is the number of people born in a given year that we still remember prominently today. Okay? So let's say when you look here at the year 0 or the year 500 BC, this is what is the probability that someone born at that time is still remembered nowadays. And the probability is quite low. We remember around, from the year 500 BC or from the year 500 AC, we would remember around 4 people per billion births per year. Okay? So the probability of producing an Aristotle, a Plato, a Shakespeare, are very, very low. But that probability all of a sudden jumps here and plateaus again, after the invention of printing. So what this is telling us is, like, for me, surprising that for 2,000 years, that number was constant in per capita terms, both in the Pantheon dataset, which is based on the Wikipedia, and in the Human Accomplishment dataset, that is a dataset that is much smaller, based on only people from the science and the arts, that was compiled in a book by Charles Murray, and that actually looks at encyclopedias in 6 different languages. So it's a different data source, but still you see the same transition. That when the printing press gets invented, there is a big change, on the number of people that we remember. And then around the year 1700, when there are new innovations, when there's what Habermas called the invention of the public sphere, when there are new formats of printing, not books only, but magazines, pamphlets, journals, newspaper, the number of people that we remember starts increasing, and our collective memory starts going up. Okay? So the fraction of people that we remember from a technological time period is bounded. We have a finite memory that's determined by technology. But what goes into that finite memory also changes when communication technologies change. So the next thing that I'm going to show you is how the composition of our collective memory changes over time. Here I have the people that were born and that we still remember, that were born before the year 1400, before the invention of printing. And you see that these are mostly political and religious figures. Yeah? So before the invention of printing, the bandwidth of our human collective memory was very small. And the only people that got remembered were institutional leaders, were like the kings, the emperors, or the religious leaders of their time. What is surprising here is that actually there's very little in the arts and the sciences. There's a few mathematicians from ancient Greece or from the Arabic countries. There's a few painters, but the painters that you observe there are mostly born in the year 1400, just before that. Donatello, 1386, Van Eyck, 1395, Paolo Uccello, 1397, Andrei Rublev, 1360, which are people that were probably alive at the time that the printing press got started, or that had recently died. So then now let's look at the world after the invention of printing, but prior to the introduction of film and radio. And when we have that, it's a very different world, in which now religious figures are only 3% of global cultural production, not 30%. Politicians are still strong, but they're not half. And now you have a lot of scientists, physicists, chemists, biologists, mathematicians, physicians. You have writers like Shakespeare, Goethe, and Voltaire. It's no surprise to me now that all languages have their most famous writer in history after the invention of printing, not before. Most languages did. You have lots of painters now, and you have composers. Okay? This is actually something that is very well documented also in a wonderful book by the historian Elizabeth Eisenstein called The Printing Press as an Agent of Change. And in the context of science, she says, before the invention of printing, the wealthiest scholars maybe could afford 2 or 3 books. And that's because they had to transcribe the books themselves to have a copy of them. Remember when you guys used to have tapes? And you had to copy the music on a tape, and the music that you were able to get would be the number of tapes that you would be able to transcribe. Well, before the invention of printing, books were the same thing, but you had to copy them by hand. Okay? But after the invention of printing, scholars like Kepler, or Newton could afford tens of books, maybe 100 books. So they would be able to read a lot of different things and then combine those things into a new narrative, into a new theory. And as you all know, books are made of books. Yeah? But before the invention of printing, people did not have access to many books at the same time. So that's also why the sciences changed so much. But they are changed too. You have painters and you have composers. Now, after the invention of printing, there's a new revolution that happens at the beginning of the 20th century, which is the invention of film and radio. And the invention of film and radio also was very sudden and created an abrupt change in our ability to remember and on who will remember. So what I want to show next is how that matrix looks like. And here now you have a world in which the arts are still big, but now they're actors, musicians, and singers. There are no composers anymore. They're not painters. Because now you have film, now you have radio. And what happens when you have film and radio? Well, now you can record the performance. So now who's remembered? The one that wrote the play or the one that acted on the movie? Who gets remembered? The one that composed the song or the one that performed it? So now there is a world in which performances are finally being recorded. And what is interesting is that if there's any people that here are obsessed with causality by any chance, you can argue that this is quite good evidence for this being causal. Why? Because actors existed all along. The Greeks had actors, Shakespeare had actors, acted on their plays, but actors never became globally famous until there was a medium capable of recording performances. Okay? The same is true for the musicians and singers. Singers and musicians are a very ancient type of occupation, but musicians and singers did not become memorable until there was a medium that was able to record the performance. And finally, we have the introduction of television, which is the internet of the baby boomers. It's a technology that comes in the middle of the 20th century, and changes the shape of the world at that time. And who becomes famous on television? It's not the same people that became famous on film, because film and television have a very important difference. Film is an asynchronous medium. Yeah? When you're watching a movie, you're usually looking at a movie that was filmed that was written many years ago, and then that was produced a few years ago, and that was filmed a few years ago, and now you're watching today. So you're not watching a live event. But when you're watching television, you can't watch live events. And what are the live events that people still watch on television? Those are sports. So with the rise of television, you have the rise of soccer players, tennis players, basketball players, coaches, and race car drivers. Television invents the famous sportsmen. They become globally famous. Because in the past, if there was someone that had a really good athletic prowess, basically you would hear about them maybe, but to be honest, seeing Michael Jordan play live on television and reading about a guy that was really good at basketball is not the same thing. Okay? There's something that writing cannot convey. Okay? That's why we have different mediums. So these different mediums are also changing who we remember. Now I see that it's like 2:50, so I'm going to wrap up, and maybe we're going to be able to look at some of the other tools, during the round of discussions. But in the interest of time, I'm going to finish here, and I'm going to say thank you very much, for your time and for your attention, and I would be glad to take any questions that you might have. Thank you.